Hello everyone, so in 12.7 we are graphing trig functions. Now, I know these look really complicated. However, so long as when you're graphing, you don't plot your points strictly from left to right, it'll be much easier. And I know that seems strange, but you'll see what I mean in a little bit. So, all of these points refer to points from the unit circle. So sine, remember from our unit circle, is the y values. So we start at 0, go up to 1, go back down to 0, go down to -1, and go back to 0. And then that repeats. So we have this sort of S wave if we look at one individual period. For cosine, remember that was our x values. So we start at 1, go down to 0, go down to -1, go back up to 0, and then come back up to 1. And then again, that repeats. So, for sine, we are starting and ending at 0, because our y value at 0 and 2 pi is 0. For cosine, we're starting and ending at 1, because at 0 and 2 pi, our cosine value is 1. We're going to focus mostly on graphing one cycle, but it does repeat. It does continue going in that exact same pattern. Our domain for both of these is all real numbers. From our parent function, the highest and lowest that we go are -1 for the lowest and 1 for the highest. Our amplitude for our parent function is 1, and our period is 360 or 2 pi. Now in this section in the book, they do it a lot in degrees. However, more often than not, you'll have to graph these in radians. If you prefer the degrees, that's fine. I have the radian equivalents down here. I'm going to focus on graphing them in radians, simply because that's, like I said, typically how you'll see them, and then in the next section, the book will also do it in radians as well. So typically, if you can do it in radians, it's pretty easy to switch back over to degrees, but mentally it's a little bit more difficult to go the other way. So I'm going to graph it in radians. Now, our general form, which will focus on shifts in the next section, but we'll have numbers in front of our function, numbers in front of like our parentheses, and then we'll have our normal h and k. So we're used to this a. Here, a is our amplitude. So it's going to tell us how high and low we go. So here we have an amplitude of 1, because we only have a 1 in front of our sign. So it went up to 1, and it went down to -1. And this is going to be in reference to the midline. Midline will come more in handy when we're actually graphing a vertical shift, but it's just that idea that you're going to go up a certain amount, but then also when you come back down, it's going to go down a certain amount. Frequency talks about how many cycles occur within a normal period. So the higher that b value is, the closer the waves are going to be to each other. H is our horizontal shift, K is our vertical shift per usual. Now at the beginning of this section in your book, there is a really nice interactive thing where you can play with shifting the A, shifting the B, and seeing what it looks like. And it actually looks just like this. So if I wanted to affect my amplitude, notice when it becomes negative, it'll flip. Affecting our frequency, so the smaller my number is, the kind of wider it is, the bigger this number is, the closer and closer and closer each individual curve becomes. Horizontal shift. And vertical shift. So that's kind of nice to play around with to kind of make those connections of what's actually going on here. So, if I was going to be graphing the amplitude and the period, So to find the amplitude, it's any sort of number that's in front of my function. So here my amplitude is 1. For my period, that's going to be based off of this number. So you can take 360 over that number, or I'm going to take 2 pi over that number, since I'm going to be graphing it in radians. So two pi over 3 is just 2 pi over 3. If I was looking at that in degrees, that would be 120. So, what I mean by don't plot your points in order. Graph your start, end, and middle. For sine, as we see on our basic sine function, we start, end, and have a middle point at 0. So since my new period is 2 pi over 3, that's approximately here. Since 2 pi over 3 is a little bit less than pi, my halfway point would be at pi over 3, just a little bit less than pi over 2. You're welcome to make your little increment marks however you feel is appropriate for your graph, which we'll play around with more in class. So I've got an amplitude of 1, so that means I'm going to go up to 1 and also down to -1. So that's like my in-between points. So halfway between my beginning and my middle, I'm going to have a maximum. Halfway between my middle and my end, I'll have a minimum. And then I'll connect my points. So that's a sine function with a period of 2/3 pi instead of 2 pi. It is shortened versus taking up this entire space. For cosine, we start and end at 1, or whatever our amplitude will be. Halfway in between, I went down to -1 for my parent graph, or down to whatever my negative version of my amplitude is, or my minimum. So, here my amplitude, my number in front is 1/2. As for my period, there's nothing in front of theta, so I have a normal 2 pi, because it's 2 pi over b, or if you're doing it in degrees, 360 over my b. So, still graph your beginning, your end, and your middle. So, here's 1/2. At 2 pi, I will also be at 1/2. In the middle, I'll go down to -1/2. My in-between points are just zeros. So in between pi and 0 is pi over 2. In between 2 pi and pi is 3 pi over 2. And I'll connect my points. So cosine looks more like a U with 1 period, although I got a little lopsided right there. Sine looks sort of like a sideways S when we're graphing 1 period. And again, we'll play around with this more in class. I just want to show you the gist of it for those that will be absent, as well as that we have an idea of what we're doing. For tangent, it looks a little bit different. This is because, well, since tangent is y over x, there's a couple times that x is 0. So I'm going to have an asymptote. My domain is going to be all real numbers except for wherever those asymptotes are. For our parent function, it's pretty much any sort of multiples of 90/pi over 2, and then adding or subtracting our period length, which is pi or 180. Range, in this case, is all real numbers, so we are going up and down forever. Amplitude, there really isn't one. We'll talk about a little bit what the A value actually does, but it's not really going to affect us much except for telling us, oh, maybe we'll flip upside down. And then our period is 180 instead of the whole 2 pi. Since halfway in between, I'm going to run into that dividing by 0 case. X-intercepts are just halfway in between my two asymptotes. So, we've got our general form. A still stands for the amplitude, but it's not really the height anymore. B is your frequency. To find your new period, you're dividing from pi, or 180 now, instead of 2 pi, or 360. H is still a horizontal shift, and K is still a vertical shift, but again, that's more next section. So, we don't have to worry about the amplitude, because there really isn't one since we go up and down forever. So we're going to graph our asymptotes in our midpoint, and then sketch in our curve. So, my period length is pi over 1/2, or 180 over 1/2, divided by a fraction. Remember, you multiply by the reciprocal, so this guy's period here is actually 2 pi. So this is wider than a normal tangent graph. My tangent, the midway point, is in the origin spot. Half of my period is going to go to the left. For my first asymptote. Half of my period is going to go to the right for my second asymptote. What the B value actually does is it tells us sort of like this in-between point. So instead of an actual like max or min, it just kind of tells us how bumpy the inside is. So if it is more kind of straight versus, you know, having a bigger difference in the middle. So my A value here is 1. So though you don't have to actually graph this point, I like to use it for reference. That way you can kind of see the difference slightly between the graphs. So just to kind of give a better flow to my points, I've got those there. And then I connect and sketch my curve. So starting by the asymptote, connect, go towards my other asymptote. I know it seems like a lot, it seems really complicated, but we'll get enough practice in class that it'll really seem at least a little bit more second nature versus something that's totally foreign. So, I'll see you then.